So let us start with problem number 2. Now in problem number 2, you see two sets that are there, A and B. Both of these sets have been given to you in set builder form. Okay. You first write the two sets in tabular form. Remember, always it is always easier to work with sets in tabular form. In fact, set builder form we use only for certain special purposes where the set is very big, okay, or the actual elements cannot be listed of the sets. For example, say a set of cards, playing cards. How will you actually list the elements? You cannot list the element. You cannot draw the cards inside the the curly brackets. So we don't use the tabular notation there. For such purposes, we use the set builder form. But set builder form is a very useful form because in fact you can denote any set with the help of set builder form. Tabular form has its limitations because just as I told you that in case of say a set of cards, playing cards, how will you denote it in tabular form? Very difficult, almost impossible to denote. So that is why set builder form is important, and you must understand set builder form. So first here, if you see in this problem number 2, the set A is given in your set builder form. The set is X such that X is a letter of the word
So can you repeat again when the means test will happen before or after Diwali?
after.
After, okay, sir.
Okay. What you do here is this is given in your set builder form. This set consists of what? It consists of the letters of the word integrity. Okay. So what are the letters here? I is a letter. N is another element. T is another element. E, G, R, I, T, Y. So this is your set in tabular form. Next, the set B. X such that X is a letter of the word reckoning. Okay, this is a word, but the set consists of the letters of the word. So we'll separate the letters. So how many elements are there in the set A? There are 9 letters, right? Yes, there are 9. And in the set B, how many elements are there? If you count R, E, C, K, there are 10 letters. Okay, there are 10 elements in the set B. Your first question here is A union B. What is this set? What is this set? This set is A this set A union this set. So what should be the union of these two sets? The union of these two sets is the elements of both the sets, or A or B or both. So I is there. If you see, I is here and I is here. So you write I. Okay. N is here. N is here. N. T. You don't have a T here, but still it is in A. So you write a T. Okay. E. E is here. E is here. So I give an E. G. G is here. G is here. You give a G. R is here and R is here. R you give here. I is here, but I we have already written, so we don't have to write again. Okay, so you don't have to write the I again. What about T? This T here, T we have written here, so we don't need to write again. What about Y? Y we have not written. Y is here. Is Y here? It is not here, but still we'll write. Why? Because it belongs to A. And what about this set? C, R is here, we have already written here. E, we have already written. C, we have not written, so we'll write C. K, we have not written, we will write K. O, we have not written, we will write O. N, we have already written here. I, we have already written here. Okay, N, we have already written here. G, we have already written here. So this is your A union B. So it consists of all the elements of A as well as B, written only once. Okay, you cannot repeat. So this was A union B. What about A intersection B? As I told you, A intersection B consists of elements that are common to both A and B. Is I common to both A and B? Yes. What about N? Yes, it is common. What about T? It is not common. E? Yes, it is in both the sets. G? Yes, it is in both the sets. R is also in both the sets. I, we have already written here, so no need to write again. T, is it common? No, T is not common. Y is also not common. So this is my A intersection B. Okay. And third one is A minus B. Okay. Now what about A minus B? How will you write A minus B? What is the definition of A minus B? A minus B actually consists of all the letters of A from which all the letters of B have been removed. Okay. As I told you, remember, if you remember the definition, A minus B is a set that contains all the elements of A but not of B. So what are the elements that are in A but not in B? I, if you see here, I is in A and it is also in B. So we will not write I. Okay. Because it is already there in B. N is there in A. N is also there in B. So we'll skip N also. T is there in A, but T is not there in B. So we'll write T. E is there in A and is also there in B. So we'll skip E also. G is there in A and it is also there in B. So we'll skip G also. R is there in A. It is also there in B. So we'll skip R also. I is there in A as it is also there in B. So we'll skip I as we had skipped earlier. T we have already written. And what about Y? Y is in A, but Y is not there in any of the element in B. So we'll write Y. So A minus B consists of only two elements, T and Y. Next, B minus A. What about B minus A? B minus A consists of all the letters of all the elements of the set B, but not of A. So if you see R, the first element of B, here, R, is it there in A? Yes, it is there in A. So we'll skip R. Next, consider E. Is it there in A? Yes, it is there in A. So we'll skip that also. C. It is there in B, but is it there in A? It is not there in A. So we'll write C. K. Is it there in A? It is not there. So we'll write K also. O. Is it there in A? It is not there in A. So we'll write O. N. It is there in A. So we'll skip N. Okay. So we have this we have written. This we have written. This we have written. N, as I said, it is there in A.
Excuse me, sir.
Yes.
Sir, Sharmishta cannot join due to a network issue.
Okay, okay, no problem. Fine.
Okay,
So
sir.
N is there in B and N is also there in A. So that is why we skip N. Next, let us see I. I is there in B. It is also there in A. So we skip I also. Again, N is there in both. So that we have skipped already. Okay. And what about G? G is there in both. So we'll skip G also. So therefore, B minus A consists of only three elements, C, K, and O. Okay. So this was B minus A. So that finishes all the parts of this question. Let us now come to the next question, which is consists of the universal set. Xi is given there. The xi we know is the universal set. Universal set is either denoted by a u or a xi. Okay. So xi, this is again given in a set builder form, x such that x belongs to w. That means w is a what? A standard set, the set of whole numbers. So x belongs to w means x is a whole number. And what kind of a whole number? It is such a whole number that it is less than or equal to 10. Okay. So if I write this in tabular form, what will I write? What are the whole number that are less than or equal to 10? These are the whole number that are less than or equal to 10. Next, we consider the set A. What kind of a set is A? X is such that, now see, the universal set is a whole number, right? And here in A, it is given x is such that x is greater than or equal to 5. If the universal set is whole number, then this x has to be a whole number here also. Okay, remember this. Even though it is not given x belongs to w, but if the universal set consists of whole numbers, then the set A will also consist of whole numbers. Okay, so that is why even if it is not given x belongs to w, you will consider it to be a whole number because
Sir, I
it
haven't
is there
understood this
in
one, sir.
the, yes.
So I haven't understood this one, sir.
See, universal
Sir,
set
your
consists
voice was cutting, sir.
universal set consists of whole numbers. Universal set consists of whole numbers. That is why whatever sets that are related to the universal set will also be whole numbers. Okay, so A here is not given x belongs to w, but we'll assume x belongs to w because in the universal set x belongs to w. So if we want to write this in tabular form, what are the whole numbers that are greater than or equal to 5? It is 5, 6, 7, 8, 9, and so on.
Yes, sir.
Okay, so this is what kind of a set is this? Can anyone tell me what kind of a set is this? Can anyone tell me what, Ayushi, can you tell me what kind of a set is this?
So the last one.
Set A.
So set A is indefinite set.
Infinite set. Fine.
Yes, sir.
Set A is
Infinite
an
set.
infinite because you cannot count the number of elements of A. Okay, fine. Answer is correct. You meant the right word. That's okay. Again, the set B, if you see, now if you remember, I told you the meaning of this. What is the meaning of this? If I write in this manner, if you remember, I told you this notation means x lies between A and B, where x can be equal to A because equality sign is there, and x can be equal to B. If I write it this way, we also say x lies between A and B, but its x cannot be equal to A. X can be very close to A, but it cannot be equal to A. But here I have an equality sign. That means x can be equal to B. If I write it this way, this also means that x lies between A and B. But x can be equal to A because equality sign is there. But x cannot be equal to B because out here you only have a less than sign. You don't have an equality sign. So always remember that this notation means x lies between A and B. So now coming back to this, when if they have written 3 less than or equal to x less than 8, that means x lies between 3 and 8. But x can be equal to 3, x cannot be equal to 8, and x is what? A whole number. So that means what is this set? X can be equal to 3, it can be equal to 4, 5, 6, and only till 7. It will not go to 8 because you see there is no equality sign here. Okay, so x cannot be equal to 8. It is absolutely clear, this concept. Please memorize this concept. This notation means that whenever x is between A and B with this sign, it means x lies between A and B. Okay, whenever you come across this kind of a sign, you will come across always that a number x written in this way, it means x lies between A and B. X is the lower number, This is the higher number. Okay, so x lies between a and b, and because the equality sign, x can be equal to a, and because of this equality sign, x can be equal to b. Okay, please remember, please memorize this, that x lies between a and b. This means x lies between a and b. These two signs have to be the same. These two signs have to be less than or equal to signs, not greater than or equal to signs. So again here, 3 less than or equal to 8 less than 8 means x lies between 3 and 8, where x is a whole number. So what are the whole numbers that lie between 3 and 8? 3, 4, 5, 6 and 7. Why 3 also? Because I see there is an equality sign here. Okay, so remember this, memorize this. We'll come across this too often. First question, now we'll start answering. Okay, so the first question here is, verify that A union B complement is equal to A complement intersection B complement. Whenever you come across this kind of a question, verification question, as I told you earlier also, you will find out the left hand side, you will find out the right hand side and show that they are equal. So we start from the left hand side. What is the left hand side? Left hand side is this. Okay, so before finding the left hand side, let us first find out A union B. What is A union B here? A union B. From these two sets, what is the union of these two sets? It is 5, 6, 7, 8, 9 and so on, right? This is the union of A and B, because A starts from 5 and B starts from 3. Okay, if you combine these two sets, no, this is wrong. This should be 3, starting from 3. If you combine these two sets, this will be 3, 4, 5, 6, 7, 8, 9 and so on. This is A union B. So therefore, what should be A union B complement? What do you mean by complement? Left hand side. This is A union B complement, this expression. What is A union B complement? What do you mean by complement?
So before.
Complement means whatever elements that are there that are not there in that set. So A union B, if it contains all these, then what is not there in A union B? 0, 1, 2. Only these three elements are not there in A union B. Am I right or not? It is there in the universal set. See, it is there in the universal set. Which elements are not there in A union B? In A union B, you see it starts from 3, 4, 5, 6 and so on. Okay, now there's a small mistake here. If the universal set consists of numbers only till 10, this is not an infinite set. This should be a finite set, because the universal set is finite. Okay, so this should be a finite set, because the universal set consists of only elements till 10 here. Okay, that is why since the universal set is finite here only till 10, that is why this set will start from 5 and will have only elements till 10. And similarly here, A union B will also be finite. That means this should be only till 10. And what is A union B complement? A union B complement are those elements which are not there in A union B. Remember, A union B complement are those elements which are not there in A union B. And which elements are not there in A union B? It is 0, 1, 2. Because see, only these elements are not there in A union B. Okay, so this is left hand side we have found out, A union B complement. Now we proceed to find out the right hand side. But before we proceed to find the right hand side, we first find out A complement. What is A complement here? A complement are those elements which are not there in A. So what are the elements that are there in A? 5, 6, 7, 8, 9, 10. What elements are not there in A? 0, 1, 2, 3 and 4. These elements are not there in A because they are there in the universal set here. B complement. What elements are there in B complement? Those elements which are not there in B are the elements of B complement. What are the elements in B? These elements. What elements are not there in B complement and which are there in the universal set? 0, 1, 2. Okay. And you have 3, 4, 5, 6, 7 there in B. So we will not write because they cannot be in B complement. So the next we'll start with 8, 9, 10. Okay. So this is A complement and B complement. Once we have found out A complement and B complement, we can now find out RHS. A complement intersection B complement. What is A complement intersection B complement? It is the element those that are common to these two sets. What are the elements that are common to these two sets? 0, 1, 2 only and no other element. So what do you see? A union B complement is 0, 1, 2, which is the left hand side. And A complement intersection B complement is also 0, 1, 2. So therefore LHS is equal to RHS. That is A union B complement is equal to A intersection B complement, A complement intersection B complement. And what are these two equal to? 0, 1, 2. Okay, we move on to the next one. For the second one, we find out A intersection B first. What is it? Because if you see in this one, the left hand side is A intersection B complement. We cannot find A intersection B complement unless we find A intersection B first. So let us first find out A intersection B. What is A intersection B? The elements that are common to A and B. What are the elements that are common to A and B? 5, 6, and 7. Only these three elements are common to A and B. Okay, so therefore, what is the left hand side? Now we can find out the left hand side. A intersection B complement. And what do you mean by intersection B complement? Those elements that are there in the universal set but are not there in the but are not there in A intersection B. So what elements are not there in A intersection B? 0 is not there, but it is there in the universal set. 1 is not there in A intersection B, but it is there in the universal set. 2 similarly. 3, 4, 5, 6, 7 are there in this. So we will skip those. 8 is not there, but it is there in the universal set. 9 is not there in A intersection B, but it is there in the universal set. Similarly, 10 is there in the universal set. So A intersection B complement is this set. Okay. Now we proceed to find out the right hand side. But before we proceed to find out the right hand side, we'll first find A complement. You have already found A complement, I think, but I have erased it. So A complement, let me just write it down once again. A complement consists of the elements that are not there in A but are there in the universal set. So 1, 0, 1, 2, 3, 4. This is A complement, and B complement is all those elements that are not there in B but are there in the universal set. So 0, 1, 2, 3, 4, 5, 6, 7 are there in B, so we will not write it. Next we'll start with 8, 9, and 10. So A complement and B complement we have found out. Now we are in a position to find out the right hand side. A complement, union, B complement. Now what do you mean by union? Union of these two sets. It consists of elements of A complement and B complement, A complement or B complement or both. So what are the set? What are the elements? 0, 1, 2, 3, 4, and you have 8, 9, and 10. That means you take all the elements of A and B and don't write any element twice. Okay. Now check. Are these two sets same? Yes, they are same. So hence LHS is equal to RHS. That is A intersection B complement is equal to A complement union B complement, which is equal to 0, 1, 2, 3, 4, 8, 9, and 10. Can you tell me what 1 and 2? Although I have given this as a sum, can you tell me what these two are called? I have told you this as a law. Can you tell me what this law is called? Both these laws. That the complement of a union is equal to intersection of the complements. De Morgan's law. Do you remember? Do you remember De Morgan's law or not? You've forgotten. Anyway, this is what De Morgan's law is, but this has been given to you as a sum. Next, third part. You need to show that A minus B is A intersection B complement. So again, we will find in left hand side and right hand side and show that they are equal. So what is the left hand side here? Left hand side is A minus B. And what is A minus B? 5, 6, 7, 8, 9, 10 minus 3, 4, 5, 6, 7. If you remember, A minus B, I told you, consists of all the elements of A which are not there in B. So what are the elements of A which are not there in B? Elements of A, 5. It is there in B, so we skip 5. Okay. 6 is there in A. Is it there in B? Yes. So we skip 6 also. 7. It is there in A. Is it there in B? Yes. So we skip 7 also. 8. It is there in A. It is not in B. So we write 8. 9 is in A but not in B. So we write 9. 10 similarly is there in A but not in B. So this is your A minus B. Okay. Now we proceed to find out the right hand side. B complement. What was B complement I found out earlier? B complement I had found out earlier to be this, right? So therefore, what is A intersection? What is the right hand side? Now we are in a position to find out the right hand side. What is the right hand side? A intersection B complement. And what is A here? 5, 6, 7, 8, 9, 10. Intersection 0, 1, 2, 8, 9, and 10. What do you mean by intersection? The elements that are common to these two sets. What are the elements that are common? 8 is common, 9 is common, and 10 is common, right? So LHS we are getting 8, 9, 10. RHS we are getting 8, 9, 10. Are they equal? Yes. Hence LHS is equal to RHS. That is A minus B is equal to A intersection B complement. And what are these two sets equal to? 8, 9, and 10. Okay. And the last part, B minus A is equal to B intersection A complement. Again, this is exactly the same, except that B and A have been interchanged. Okay. So we first find out B minus A. B minus A. 3, 4, 5, 6, 7 minus A. 5, 6, 7, 8, 9, and 10. Now, what is B minus A? All the elements of B which are not there in A. 3 is an element of B. Is it there in A? It is not there. So we'll write 3. 4 is an element of B. Is it an element of A? No. So we'll write 4 also. 5 is an element of B. It is there in A. So 5 we cannot write. Similarly, 6 if you see is there in B. So we cannot write. 7 is also there in B. So only 2 elements in B minus A. Okay. Now A complement. We had found out A complement. Let me just write this. A complement is again 0, 1, 2, 3, 4. Only this A complement. Okay. A complement means all the elements of A which are not there, all the elements which are not there in A, but are there in the universal set. I had written this earlier also. Now we are in a position to, this is your left hand side. Now we are in a position to find out the right hand side also. B intersection A complement. And the set B here is 3, 4, 5, 6, 7. Intersection 0, 1, 2, 3, and 4. What are the elements that are common to these two? You see that 3 is common, 4 is common. Any other? 5, 6, 7. Nothing is common. You're only getting 3 and 4. So what do you see? B minus A is 3/4, and B intersection A complement is also 3/4. Therefore, we have verified. Hence, LHS is equal to RHS. That is, B minus A is equal to B intersection A complement. And what are both these two sets equal to? 3, 4. Okay, so this exercise is complete. I stop here for today.